Stephen, you had a breakthrough that can show Einstein that he was wrong. Is that so?
Yeah, and quantum mechanics.
Nice.
Yeah. I guess I'll try to give you a 60-second overview as practice for future interviews. But I found that if you require the rules in the laws of physics that have mathematical operations, if you require those math operations to correspond to something that is physically real and persistent in the universe that your physics laws describe, it actually becomes a requirement that general relativity and quantum mechanics cannot support.
Yeah, they conflict each other. General relativity and quantum mechanics, they conflict.
Well, what I'm saying is the rules of general relativity, the math that they use conflicts with the reality that the equations describe. The easiest way to say this is Einstein bases his whole theory off of what's called the Einstein equivalence principle, which says is if you are to take any piece of space and you zoom in closer and closer and you measure the gravitational differences in these tiny regions, the differences become zero at a point. And the way that is constructed is by taking smaller and smaller chunks and taking a measurement. And so in order for that rule to work, you need to be able to take measurements, and you need to be able to take those measurements at arbitrary lengths. And what happens is with Einstein's equations, if you run those equations with inputs that are like the same universe we live in, that has a cosmological constant that causes the universe to expand, then it actually makes it so that you cannot always do that measurement. If you were to take, in order to do a measurement, you need energy. So if you fix the amount of energy that you have and say, hey, let's construct a measurement device with this energy, after a finite amount of time, it becomes impossible to construct the measurement device. So the actual rule that Einstein bases his theory off of, the places in the universe where that rule can be checked goes to zero as time goes to infinity. So the actual places where the Einstein axiom is valid in the long run is nowhere. It's valid now in a local time in a small chunk of our space time.
Right.
But if you say that the equations have to be consistent forever, they don't. The only way that the physicists get around this is they say that the math doesn't have to be something that is part of reality, which I find to be a philosophical mistake in a way. Because what they're saying is some entity external to the universe is what creates the laws and ensures holds up. I think that's theology and not physics. And quantum mechanics is sort of the same, where the way that they design the math is they use something called infinite Hilbert spaces, where each point in space has an uncountable infinity of possibilities, and there is no way to prove that is possible, and there's no experiment you can do to show that's possible. And all of the part of the theory that it's based off of that has very little or no experimental proof for it. They've actually hit a wall in quantum computing where you're supposed to be able to put as many quantum bits together into one state to do a calculation, but they've never gone beyond 3 qubits to do the real core computation needed in what's called the Shor's algorithm.
All right, that's been there's been a lot to dissect here. Oh, yeah. I wonder if you want to simplify it to be understood. Is that even possible to simplify it? So we have 2 things. General relativity, I think I understood that. Einstein equations, they work only in the local universe. If we expand beyond our local universe, they break apart. And same goes for the law of conservation of energy. Energy is only conserved in the local universe, but if the energy travels from different local universes, it loses itself. It's weird. You know about that, right?
Yeah, the interpretation of quantum mechanics has almost like a nonsensical formalism, where the way the theory developed was they had classical physics that could describe things pretty accurately, but then they had some issues when they were measuring how temperatures of certain objects would emit light. That if you had something called a black body, where you have like a spherical region that you poke a hole into, it didn't matter what your material the sphere was made out of, the amount of light that would come out of it if you heated it was a same type of light. The wavelength and the curve of that light was sort of identical, and none of their theories could match that curve until they realized that they had to sort of cut off their classical predictions. Their classical predictions said that there's infinite number of wavelengths you can have inside the sphere. You can have a wavelength of just like one from edge to edge, or two, like double, like an octave higher, where you have two peaks on your wave, or four peaks in your wave. And their math doesn't limit the amount of peaks of the wave that belong in there. And so what happened was, when they would run the calculations, they would get curves that didn't match reality. And then at some point, they discovered that if they say that there's like a finite floor to the width of that wavelength, then it would match reality, which is, by having that finite floor, is what quantized it. And other experiments popped up where they couldn't tell, like light sort of behaved like a wave and a particle at the same time. And so the equations that they used to model the behavior work really well at describing the probabilities that they would get for running their experiments. You can never predict exactly what would happen, but they could give you sort of the distribution of what will happen. And so right around like 1927, they came up with the wave equation that sort of captured the quantized component and the probability component, and was able to accurately describe the how like the shapes of the electrons in the orbitals would look.
Yeah, the electron cloud, the probability cloud.
And so what happened is that essentially it became like a religion, where they thought that the mathematical language that they developed, because it was accurate, is the actual description of what reality is doing, and not just what it really is just an approximation to what reality is doing. And because they don't realize this, and they think that their equations are the like real thing the universe is doing, there's so many different ways to interpret it, because it's not based in reality, that you get things like we could have multiple universes, or bubble universes that have energy coming from in and out, or multiple dimensions beyond just the three of space that we experience. And it kind of became there was a long time where, after they discovered the wave equation, for almost 20 years, the theory was broken, because the electron itself, if you calculated how much like energy it has, it essentially would be infinity. And they couldn't use it in their equations, because you can't just plug infinity in and add it to other stuff. And so in the 40s and 50s, they developed a way to mathematically cheat and cut off some of the values and they call it reinterpretation. And they do the cutoff by taking measurements from real life, plugging the measurements in, and replacing the infinities with the measurements to get other predictions. And that process, it took 20 years for them to figure this out. And since then, it's sort of done really well at predicting certain things, but it also has a lot of issues that no one has ever told about. They say quantum mechanics today is the most accurate theory of all time, but they only have a certain range of like experiments where that's actually true. They found some experiments now looking at like DNA molecules, where the quantum mechanics predictions were off by orders of magnitude. So like 1,000% or 100,000% wrong. And it was something that I had no idea was the case until I started researching for my book about, how should we really approach physics, and what kind of theory should we develop if we start with that original rule that I mentioned, which is the math needs to correspond to something real. And that's that story, I guess.
Right. So there are flaws in general relativity, and there are flaws in quantum mechanics theory. And what you discovered is what exactly?
I discovered that the flaw is there because we're missing a principle of physics. There's plenty of principles, like the principle of relativity says the laws of physics should be the same everywhere in the universe. There's also other principles, like Newton's principles of like equal and opposite reaction, or the principle
the
you mentioned
fundamentals
earlier.
of physics, the symmetry.
Yeah. You mentioned a principle, conservation of energy. That is a principle. That's not something that's proven. It's just something that they assume to be true.
A constant, right? The constant. The speed of light is a constant, cosmological constant.
The speed of light being constant is is something that they've tested and determined to be locally true. It's originally derived from the Maxwell's equations for how electromagnetism is modeled.
Right. But let's not deviate there. There are constants that were proven, and there are principles that are not proven, like the conservation. So you found a new principle, you're saying?
So I independently found a new principle. I found out later that famous physicists like Einstein and Dirac and a few other guys also proposed this principle, but they never did anything with it. And that principle is the rules of physics should be written with reality, not with fiction math, is what I call it. So math, they allow infinity, they allow uncountable infinity. Dividing by zero is something that physicists sort of allow you to do now. And I say that the language, if the rules of the universe are actual rules that we can write down completely within the universe, I believe it has to be something that corresponds to objects and actions that the universe is proven to be able to do. And so Einstein and Dirac thought this was the case too. They really looked at quantum mechanics and said that, hey, all this math you're using is crazy math. It doesn't make any sense for physical reality to be based off of that. But they never applied that to general relativity, because if they did, they would have found out general relativity has the same issue. And
general relativity, it's all just formulas, meaning math, isn't it?
Yeah. And like I mentioned earlier, one of the math formulas ends up breaking in the physical reality that the formulas describe.
Well, let's take the Einstein's famous equation, E equals mc squared. It hasn't been proven by reality, has it?
It's been experimentally tested pretty accurately. That theory is it captures a concept which is probably true, and I do think that one is true.
I'm still trying to get at your principle that you discovered. You're saying you discovered that physics shouldn't use theoretical math?
Correct. Physics needs to use math that is proven to be something that reality can do. So you can't use it.
Well, sometimes, like Einstein, when he derived that equation, he couldn't prove it back then, but after generations, it was proven true.
It took him about a decade to develop the math, because he wasn't an expert in the math.
That's true. That's right. He wasn't even doing that. Yeah.
Yeah. There's a whole can of worms I can get into with relativity, because like they say, yes, it's true and it makes predictions, but all of the calculations that we do for general relativity actually doesn't use general relativity. They use Newton plus some extra terms in the expansion. Like Newton says everything's 1 over r squared. It turns out if you say it's not just inverse square, it's inverse square plus an inverse cube and then plus 1 over 4 x to the fourth. You can keep that series, infinite series, going as long as you want, and add terms to multiply each term in the series by, and arbitrarily approximate Einstein as much as you want. The only difference is when you do that, you don't consider space to expand or contract, whereas Einstein's ontology says it's the space that's expanding and contracting. So there's two ways to look at it. You can think of it as Einstein says space expands and contracts, or you can think of it as Newton's force is what expands and contracts, and you can get the same answer. But people just prefer the space expanding and contracting because it's, I guess, a cooler thing to think about.
So your principle, what can you give a real life example where it would be useful?
So I guess,
or is that the wrong question?
It's useful for determining if a physical law from physics is a valid law that could be a candidate for the final law that the universe uses. What I try to do is say that we can of mathematics into fiction math and nonfiction math. And what nonfiction math is sort of like the math that a computer can do. And what I did with my theory was I looked at not just a classical computer, which uses bits of zeros and ones, but I had imagined an analog computer where you could have your word registers, the things that store information, could be actual spheres or gears. You can make gears gear together and build a computer out of. And so what I am basically saying is you should be able to write down the fundamental laws of the universe by building a computer that replicates it. And what they do now is they essentially say that with the math that they use, you can't do that because you can't instantiate infinity. It's not something that's real, but it's something that they use in their language to describe what they think reality is doing. And that's what I believe is the main issue in fundamental physics right now, is that they rely on fiction math, stuff that is like unicorns and Santa and fairy tales in order to describe how reality should work. And
can you give me an example where they rely on fiction math to describe reality, and who exactly relies, maybe?
Yeah. So the way I design the principle is to say it's recursive. So whatever theory of physics that you write down, it is describing like a toy universe that you can calculate based upon those equations. And what I say is the fiction math is any type of rule in the original laws of physics that you cannot represent in the toy universe that you make. Mm-hmm. So it's sort of like an easy way to think about this is, have you ever played Minecraft? Mm-hmm. So in Minecraft, it's possible to build a computer in Minecraft. Have you seen videos where they do this?
Yeah.
Well, they make like redstone computers. They started off making giant calculators and then making giant like screens. They have computer screens that are built in Minecraft with the rules of Minecraft. And they found out that eventually you can simulate all of Minecraft in a computer in Minecraft. And that means that the Minecraft world is sort of complete in a way because you can build Minecraft in Minecraft. And if the rules behind Minecraft were not written down in a computer programming language, if they instead used uncountable infinity or like a continuous real line. So Minecraft uses chunks, like every single block is a block. There's no like half blocks or quarter blocks. You can't infinitely chop down your blocks because that would break the system. It wouldn't have the memory to store that. And so that's why it's able to do that in a valid manner. But if you were to say the actual universe has that capability, that would mean that you can't use infinity in the math that you use to describe reality, just because it's not logically consistent. You end up getting all kinds of paradoxes.
Right, I get it. Yeah, I'm against infinities. And when, there are a lot of videos, I'm not sure if you watch them, Veritasium, They were like this infinity hotel that has infinite rooms, and then they're all full, and then one bus comes over and they bring one more resident to the hotel. So like it's all those mind games. And like, no, you don't understand. Like, to me, you don't understand infinities. It's something like, if there is an hotel with infinite amount of rooms, then there is nothing left in this universe. There's just the infinity is not comprehensible to human mind. You cannot just think of infinities and add +1. It doesn't work like that. I don't know. It just breaks my mind all the time. But what about the Planck? The Planck length, the Planck time, the Planck second? I mean, that kind of seems to be a building block of our universe, isn't it not?
It is, in a way, for quantum mechanics. Quantum mechanics, it essentially. When I first mentioned that they had the curves that weren't matching up because they were using infinite division, as soon as they put the floor,
that's when the Planck comes in.
Yeah, that length, that floor is the Planck length, and it's not something that the theory predicts what that length should be. It's something that they have to measure and plug into their equations to tune the equations to make it work. And I think that a real theory of physics will not have any parameters that you have to tune from measurements. I feel like that's saying that if that was the final fundamental law, then that means there had to be some entity there that set that parameter before the universe was kicked off. And I feel like that's sort of allocating some of the work to theology as opposed to physics. But I do want to circle back on that infinity thing that you mentioned. Have you ever heard of the Cantor diagonalization argument, where they show you there's uncountable infinities?
No, but I might have heard of it before.
It's essentially where they say, if you had the full line where every point on a line corresponds to a number.
Oh yeah, then you move it. Yeah,
and that number has an infinite decimal expansion.
Yeah.
The way they try to what Cantor showed was, if you were to write down a list of these numbers, like this.
Yeah,
like
and
here's
then
a list.
You move it one line. Yeah.
Well, he says that if you circle the diagonals of those numbers like this, like if I circle these diagonals here, you can generate a new number where you flip the bit. So if this first one's a 0 in the first index, you turn it to a 1. If the next number is a 1,
and thus you create new infinity, new number to infinity.
But what's going on here is when they tell you that this is what they're doing, they're lying to you. This is how Cantor originally came up with it, but it was discovered later that argument is false. It doesn't work. But what happens is, when he says you can put a list of all of the real numbers, he does that as an assumption in the proof. So he assumes that they have like a pool of the infinite numbers to take from and put them in the list.
Exactly. There's no list that can hold infinity.
Right. And so, but he shows you that, okay, well, we can infinite numbers that are countable, like the integers 1, 2, 3, 4, 5. And he wants to show that there's infinities that you can't count that escape that. And this is what the diagonalization does.
Yeah.
Because if the theory says, if this list was complete, it would have every single continuum number. But if it was
complete infinity.
Yeah, and he shows it by saying, if you take the first digit of the first number in the first index and you flip that bit to a different value, and you flip the second number in the list, and you go to the third number and you flip the third number in the list, what that means is at index X, whatever your index is, if you change the bit of that index so that it doesn't match what was originally in the list, he shows that the number you construct cannot be in the list because you've changed whatever index it would be at. It can't be there because it has that bit changed. Like at index 10, digit number 10 is not the digit that's in list index 10. And so he constructs a brand new number from a list that was originally proposed to have all of the numbers. And because he's able to produce a new one, he's saying that you didn't have all of them in the first place. So that means that there's an infinity that you cannot count. That's the argument. But the argument is a fallacy. Takes a lot of you okay?
Yeah, I'm here.
Okay. It uses a lot of assumptions that are total nonsense assumptions, and part of that is 150 years later, a guy named Gregory Chaitin showed that he invented a number called Chaitin's number, which is a number that exists in the real number line that is impossible to compute any digit of it at any given index. If there's no algorithm the digits of this number. And he also showed that almost every number in the uncountable infinity has this property where you cannot generate the digits from a logical process. There is no mechanism to generate those numbers, which means that you can never put that number in the list at an arbitrary point, because if you did, making this diagonal would have access to every digit in that number. And that means that the whole idea of putting an uncountable number in a list is doesn't make sense. And what his argument doing logically is saying, if you take a list of all of the numbers that don't exist, I can prove to you that you missed another number that also doesn't exist. And so it's logical nonsense. There is no uncountable infinity. And I believe the concept of a complete infinity is a logical oxymoron. And this is what you believe.
Yeah.
I believe infinity is a verb, not a noun. So it's a process. You can always add one to the next number, but you'll never have every number at once. And that is sort of what got mathematicians and physics screwed up for the last 150 years, because they accepted the ability to consider all of the infinite numbers as a single class that can be logically manipulated, and all it does is produce paradoxes.
Yeah, that's what I would call unicorn math. Like,
yeah, and that's the problem. Is physics is based off of unicorn math.
Well, I wouldn't say physics is based on it. I can't imagine infinities being in some serious equations. Like, let's say to build a James Webb telescope, I'm pretty sure no infinities were using the equation to build.
Oh yeah, no, they're doing engineering there. But the actual laws of physics, because they use math as the language, they have permitted that language to include infinities, and it is fundamental to the theory.
Yeah, it's like infinity, like you said, it's a good analogy. It's a verb. It's almost like saying infinity is like a equal sign, right? You're not making equations with the equal sign. It's just part of the structure, sort of thing.
Mm-hmm. Yeah,
that's very interesting. So you sent me a screenshot saying your paper was ranked the first or something like that.
For physics papers at this AI preprint site called ai.vixra.org, my paper got just about it's sitting at about almost 1,070 downloads in the last month, and in terms of like download rates, that's one of the highest on the website, and it's the one that's gone the fastest. And I believe for physics, it's the #1 physics paper. There was one from a year or two ago, but it only pretends to be physics. It's about 90 pages of physics and then 20 pages of 90 pages of old physics that there's nothing new. And then they try to apply that to consciousness, which is not really physics. There's another category for that. Somehow they snuck it into the physics category. So I would say mine's the only like most popular real physics paper. And how I went through that was, so they say that a continuum, every point on the space of continuum has a number that's an infinite number that represents that point. And I said, well, we have to get rid of that. The universe can't be using unicorn math in order to describe or to process all of the like physical actions that happen. It's a total fantasy to believe otherwise. Mm-hmm. And so I realized that the only way that it could really work, and I was able to sort of come to these conclusions because I've been a programmer for like 15 years, is they need to really use techniques in programming and like video games and learn how like simulations run to make sure things are running accurately. But I realized there's only one way to do that in a way that can explain everything at all scales at one time, and that is like with what I call like recursion. A recursion is sort of a program that will execute itself. So it's like a function that will execute itself. It's if you have like an operation where one of the actions that you feed to that operation is the operation itself, it creates a logical loop which can generate all kinds of things. It's how you generate fractals. One of the most simple fractals is the what do you call it? Is the Mandelbrot fractal, and it's just this function. It says that your next number is equal to your current number plus a constant, and then whatever you take your current number, add it to a constant, plug it in, and you just keep plugging that in over, like you just go in a loop. When you go in that loop, you generate that Mandelbrot set. It's like a fractal structure. You can zoom into it, and it'll have basically unbounded complexity. And I realized that a simple rule can generate incredibly complex behaviors through like a fractal generation mechanism. And that is something that both quantum mechanics and general relativity explicitly forbid, is fractal structures in the space-time that they use. And so I thought that was my first clue, was if we get this much complexity and it's encoded into simple rules, it's probably some fractal structure and not some set of rules on random infinite maths. I found out which fractal it was and how it works, and basically think I've solved all of like the final fundamental laws of physics. All of the parameters that they tune by measuring reality, I was able to predict those parameters from the fractal structure without measuring reality at all. And when I got that, I was like, this has to be right, because no one's done that ever. And it's what, if Einstein had discovered this, I kind of figured this out over the last 9 months. And just about 4 months ago, I had like the final proof of this. And if I was Einstein and as popular as Einstein, they would have said physics is over already. But I'm sort of just like a nobody, so nobody is really paying attention, except for, I guess, the 1,000 people that downloaded my paper.
Yeah. Well, I mean, I understood only a fraction of what you said, but
okay, I'll make it easy then. When quantum mechanics tested the predictions of the wave equation to get the shapes of the electron orbitals in an atom, the way that they do it is you can't look at an atom. You can't look at it. Because when you looking at stuff is putting light into it. Exactly. And when you put light into an atom, the atom absorbs the light.
Yeah.
And then and you can't like electrons don't absorb light. So you can't look at an electron. And so what they have to do is sort of work backwards, where they can take electrons and fire electrons at atoms and look at how that electron bounces off the atom and lands like on a screen or whatever.
Mm-hmm.
They call this like a recoil experiment. And so they fire thousands or tens of thousands of electrons at an atom and look at how the electrons scatter off of it to sort of cast a shadow of the electron orbital. And what they found was that those shadows, when you put them backwards through the math to kind of calculate what that 3D shape is, was matching up very accurately with the Schrödinger wave equation. And that's how they really got the first indication that quantum mechanics is right in some sense.
Mm-hmm.
And the way I thought of it was, well, imagine if we were just like a tiny little speck and our galaxy was an atom. So that would make our stars electrons. If there was a giant flying spaghetti monster whose atoms were made out of our galaxies, and so that flying spaghetti monster's electrons were made out of our stars.
Yeah.
If you ask that spaghetti monster, what is the shape of the star orbitals in a galaxy, the only way they could test it would be to shoot stars at the galaxies and see how those stars deflect and do the same exact experiment we did. And if you run this experiment, they wouldn't get the answer, it's the disk. They wouldn't get the answer, it's the disk, because 85% of the mass of a galaxy is the dark matter that we can't see. So all of the deflections of the stars would go into the dark matter region and get deflected by the dark matter. So the picture that they would build, 85% of it would look like a dark matter halo.
Mm-hmm. So you're saying there's something unknown going on in the electron?
Yes. We sort of went backwards. When we looked at galaxies in the 1970s, we saw that the stars are going too fast for how much gravity that we
created dark matter to explain it.
And the way that they get the answer, where is the dark matter, is they look at the speed and then they try to put random dark matter in certain configurations until they get something that matches the speed. Right now, there's 4 competing models of what the shapes are, and there's no real overlap between them. There's no scientific consensus about which is most right, and so they're just guessing. And so and that affects everything in cosmology, because all kinds of dark matter patches are out there that are changing the flow. Sort of have to pick and choose which model of dark matter you think it is. So have you thought of that? Which model? Do you believe dark matter exists, or there's another explanation? I believe dark matter exists, and I believe all their models are wrong. I think the correct model is to use the same shapes that the hydrogen orbitals have for their electrons. So there's a really cool one, and it's shaped like this. Let me draw it for you. It's shaped like this. It's got 2 lobes and in a disk. And this is the hydrogen 3D sub Z squared orbital. It's like there's certain different energy levels. It's like the 3rd energy level for a hydrogen orbital. And so if you get enough energy in a hydrogen, the apparent electron distribution from recoil will look like this.
Yeah.
And right now there's another mystery in astrophysics about our galaxy called the Fermi bubbles, where when you look at our galaxy, above and below the plane, there's these regions of empty space that are emitting X-rays from nothing. They don't know what it is, what's causing it, there's two competing explanations. They both have errors in the explanations, and it's sort of an open problem in physics. But I noticed that it has the exact same shape as this. And so I realized if the hydrogen orbitals are the shape of our Fermi bubbles, and it's the shape where our dark matter is, and if the reality is a fractal, then we should have the fractal equal object should have equal dynamics. And I came to the conclusion that a galaxy and an atom are the same fractal object because they have the same dynamics. And it's because they have the same shape for the orbital of the hydrogen atom.
Right, and that would suggest that the black hole in the center of the galaxy is the proton and neutron's core.
Yes. Yeah. And what happens is because...
Wait, and protons and neutrons are made of quarks, and quarks are just waves in the fields. Everything is a wave in the field.
It is in physics, the mathematics that they use to describe the standard model. Impossible to isolate a quark. If you put enough energy to split quarks up, you just make two new protons.
That's right. You just make more quarks.
You don't make more quarks. You make more quarks, but the quarks automatically get glued to the protons. So you can never isolate them. And it's more of a mathematical bookkeeping to make their model work than it is a prediction of a real particle that exists. But because as soon as you come up with the possibility that it's a fractal and atoms and galaxies are the same object, that means you can keep going down the fractal scales or keep going up the fractal scales. If you go down a fractal scale, where if you say that in a normal hydrogen atom has an electron, but that hydrogen atom is a galaxy and that electron's a star, then that means that there has to be interstellar dust and gas that can combine to make electrons. And what happens is the places that have the most density of that stuff should be visible to us, because when stars collapse into objects, they release a ton of energy. And the Fermi bubbles are emitting X-rays, and we don't know what's emitting them. And so because I think the Fermi bubbles is the dark matter, and the dark matter is then the hydrogen atoms of the next lower layer, which is orders of magnitude smaller than the Planck length, when it gets enough density to undergo fusion, it manufactures our electrons and emits the X-rays in the Fermi bubbles. And so this is like the closure of the theory that I found, that if I can get a scientific grant to test Fermi bubbles as dark matter distributions, and it matches the curves for the stars around the galaxy better than the four models we have, that would essentially prove my theory is correct, at least computationally, or it'll be heavy evidence in favor for that theory. And
what kind of experiment would you need to run to prove it?
I would build the same simulations that they use to simulate galaxy rotations with arbitrary dark matter distributions. Mm-hmm. And I would just make the distribution shape the same as the hydrogen orbital, or the same as the Fermi bubbles.
Oh, you would apply the distribution of hydrogen atom to the galaxy.
Yes. And I think if you do that, you get the right answer.
See if the resulting radiation matches the reality.
The radiation, and if you get the spin of the stars around the galaxy.
Right, and the speed and the radiation, if matches reality.
If you get both of them.
What do you need for that? You need for that like a supercomputer that can run the simulation.
It's about, I can do it. I can write all the code myself. I think I could do it on an NVIDIA Jetson Orin, which is like a $4,000 computer. So I have to get a real job. I've got interviews next week, so hopefully those go well, and it'll be my side project for a few months.
All right, I'll stop recording. Right, that's pretty fascinating. I'm gonna upload it onto my backup channel. Hey, this is gonna be online. Anybody? How should we title this video? A break.
I don't know. There was one last thing I wanted to mention though about photons, because we think black holes are at the center of galaxies.
Yeah.
And I realized one of the big problems I had going through this theory is once I realized that galaxies and atoms were the same thing, I realized if a star gets flung off of the galaxy, it becomes an electron. But I didn't realize how it became a photon. Like, how do you get, where are the photons? Where are the light particles, the giant photon light particles? It took me a bit to figure that out, but I finally, that was like a eureka moment. I very few people in history get to feel it, and it was like being on drugs when I got it. Thank God. I realized that when a star falls into the black hole, it accelerates to the speed of light, and so whatever is going on the other side of that black hole, that star has been turned into like a giant photon. And so I realized that photons are just electrons that collide with protons. And so when that collision happens, that flings them off at the speed of light.
Photons are electrons that collide with protons.
Electrons that collide with protons become light. So it's like when a star collides with a black hole at the center of a galaxy, it becomes what I call a macro photon. It's something that we can't observe because it's moving faster than the speed of light. And people say, well, stuff can't move faster than the speed of light. But there is a solution to Einstein's equations that allow it to happen. And people didn't believe in black holes. Even Einstein didn't believe in black holes because there is an infinity at the middle. It divides by 0. Mm-hmm. But there is a solution to the black holes that violates other laws of physics, but gets rid of the singularity and turns it sort of into a wormhole so that stuff gets transferred between the wormhole instantaneously. Mm. And that's how photons work between atoms. When an atom releases a photon, it travels at the speed of light, but that's only from our perspective because time and space are relative. If you were the photon, the time it takes to travel from one atom to another is instant. Yeah. Yes. And so I realized that if a star falls into a black hole at the center of the galaxy, it will shoot out a black hole at a different galaxy instantaneously. And it happens at the jets. It doesn't happen. So the stars fall into the equator. They zoom across the universe and shoot out at the jets of a different black hole. And we see black hole jets that look like they're going faster than the speed of light. And when scientists saw that, they said it has to be an illusion. But I think the reality is it is going faster than the speed of light. We just don't realize it because our models are wrong. And
what exactly is going faster than the speed of light? A photon?
A star that falls into a black hole.
A star that falls into one black hole comes out from the jet of another black hole faster than the speed of light.
It travels between them faster than the speed of light.
Oh, it travels between the black holes faster than the speed of light.
Instant. It's instant.
It is because it's a wormhole.
Yes. And then the jets, we see jets that appear faster than the speed of light right now. That's something that is known in astrophysics, but the explanation is always it's an illusion. I think they're wrong. I think it's real.
I haven't heard of something traveling to the speed faster than the speed of light because, on the other hand, how do you detect it as faster than the speed of light?
Yeah.
So the interesting part about to me is because we're so used to having atoms, but there's matter that's not made out of atoms, like neutrinos or like a completely different dimension of what matter could be that could travel faster than speed of light as well. Yeah. Who knows? No. Dark energy could be one of those, also not made of atom. It's just, as far as I come to realize it, everything is a field. And like they say, electron is just a vibration in the field. Everything is a vibration in the field, and who knows how many of those fields there are? And we just discovered what, 4 or 5?
Yeah. The neutrino story is funny. Originally, quantum mechanics, up until the 1990s, said that neutrinos have no mass. That's what all their equations predicted. And then some Japanese guys proved through experiment that neutrinos have mass.
Yeah.
And they found three flavors of these neutrinos.
Yeah, when they collide, atoms, neutrinos come out as mass, extra mass, whatever. Dude, that's fascinating. You're so knowledgeable in physics and math and programming. That's probably your edge, huh?
Yeah, right now I think I know more about fundamental physics than anybody else in the world. And what's going on is like quantum computing is impossible. What they're trying to do is impossible. They are on a wild goose chase, but the goose is already flying and they're chasing the shadow on the ground.
Huh. Yeah, because as far as I know, they try to operate with qubits, which have infinite positioning.
Right.
And that's unicorn magic.
Yes.
Isn't it so?
There's only one metric to determine how good a quantum computer is, and it's by doing the calculation that requires using those infinite modes of entanglement. And so far, they've only been able to do it with 3 qubits, and it's been that way for 25 years.
Huh.
Every other thing since then has been either a variation on those 3 qubits or something else not related.
I think we'll call this episode Unicorn Magic: Why Quantum Computers Cannot Exist.